On August 12, 2026, something extraordinary will happen above Europe. The moon will move directly in front of the sun. For a few brief minutes, daylight will disappear. The sun will become a black disk surrounded by a glowing white corona. Temperatures will drop. Animals may behave as if night has suddenly arrived, and millions of people will look upward. But there is something strange about this event. The moon is about to position itself directly in front of an object with a surface temperature of roughly 5,500 degrees Celsius. So why doesn't the sun burn it? Could the moon ever get too close? And if the sun and moon appear to touch in our sky, could they actually collide? The answer reveals something remarkable about the total solar eclipse of August 12, 2026. The path begins over Siberia, sweeps across the Arctic, Greenland and Iceland, crosses the North Atlantic, and then reaches Europe. Northern Spain and a tiny corner of northwestern Portugal will lie inside the path of totality. For the Iberian Peninsula, this is historic. More than a century has passed since a total solar eclipse crossed the region. The maximum duration of totality, 2 minutes and 18 seconds, occurs over the open ocean west of Iceland. By the time the moon's shadow reaches Spain, the sun will already be sinking toward the western horizon. Totality arrives just before sunset, a darkening sky, a setting sun, the moon sliding across it from below. With clear skies, it could be one of the most dramatic eclipses of the century. But how can the moon cover the sun at all? The sun is enormous. Its diameter is roughly 1.4 million kilometers. The moon is only about 3,475 kilometers across. You could place roughly 400 moons side by side across the diameter of the sun. And yet from Earth, they appear almost exactly the same size. That is because the sun is also roughly 400 times farther away. The difference in size is almost perfectly canceled out by the difference in distance. From Earth, both objects occupy roughly the same half degree of sky. That cosmic coincidence allows the moon to cover the brilliant solar surface while leaving the sun's outer atmosphere, the corona, visible around it. A black circle in the sky, ringed by the ghostly light of a star. But are the sun and moon actually close to each other? Not even remotely. The moon is roughly 384,000 kilometers from Earth. The sun is around 150 million kilometers away. During an eclipse, sun, moon, and Earth have simply lined up from our point of view. The moon is not moving toward the sun, so they cannot collide. Their apparent contact is nothing more than perspective, and the heat is not a danger either. A solar eclipse does not bring the moon any closer to the sun. Its surface is exposed to intense solar radiation every lunar day. Near the lunar equator, daytime temperatures can reach around 120 degrees Celsius, while nighttime temperatures can fall to around minus 130. The moon experiences these enormous swings because it has virtually no atmosphere to distribute heat. A solar eclipse can only happen during a new moon. The illuminated half faces the sun, while the side facing Earth is mostly dark. So while Earth witnesses one of nature's most extraordinary events, for the moon, almost nothing unusual is happening. Then why doesn't this happen every month? Because the moon's orbit is tilted by about 5 degrees relative to Earth's orbit around the sun. Most months, the new moon passes slightly above or below the sun in our sky. Only when the timing is almost perfect, when the moon is near one of the points where the two orbital planes intersect, can a solar eclipse occur. And even then, totality covers only a narrow strip of Earth. Somewhere on Earth, a total solar eclipse occurs roughly once every 18 months. But at one specific location, the average wait is measured in centuries. That is why people travel thousands of kilometers to stand inside a shadow that may last only a few minutes. Because being close is not enough. Even with 99% of the sun covered, daylight remains and the corona stays hidden. Inside the path of totality, the final sliver of sunlight disappears. Then everything changes. In the final seconds, shadow bands may ripple across pale surfaces. The sky falls into deep twilight. The horizon can glow like a 360-degree sunset. and bright planets and stars may appear. Birds may stop singing, bees may return to their hives, and around the hidden sun, the corona suddenly emerges. Normally, it is overwhelmed by the brilliant solar surface. During totality, for a few moments, the outer atmosphere of our star becomes visible to the naked eye. That is also why eclipses remain scientifically valuable. For the 2026 eclipse, NASA will even chase the shadow from the sky. A WB-57 research jet flying at around 50,000 feet will follow the eclipse path, extending its view of the corona to nearly 3 minutes. Scientific balloon experiments will also study how Earth's atmosphere reacts when daylight suddenly disappears. But there is one real danger, not for the moon, for us. Sunlight entering the eye is focused by the cornea and lens onto the retina. Looking directly at the sun, even when most of it is covered, can cause permanent retinal injury. The retina has no pain receptors, so damage can happen without any immediate warning. Ordinary sunglasses are not enough. During the partial phases, observers need certified solar viewing glasses or properly designed solar filters. Cameras, binoculars, and telescopes also require filters mounted in front of their optics. Only during true totality, when the bright surface of the sun is completely hidden, can observers inside the path briefly look without eclipse glasses. The moment sunlight returns, eye protection must go back on. And there is one final twist. Total solar eclipses will not exist forever. The moon is slowly moving away from Earth by about 3.8 centimeters per year. That sounds insignificant, but over hundreds of millions of years, it changes the geometry. As the moon moves farther away, it appears slightly smaller in our sky. Eventually, it will no longer be large enough to completely cover the sun. Future eclipses will leave a bright ring around the moon instead. The perfect black disk of totality will be gone forever. NASA estimates that this will not happen for more than 600 million years. But one day Earth will experience its last total solar eclipse. Spain, meanwhile, is entering an extraordinary period. It will experience 3 major solar eclipses in less than 3 years. The total eclipse of August 12th, 2026, another total eclipse on August 2nd, 2027, and an annular eclipse on January 26th, 2028. On August 12, 2026, the geometry will align once again. Across a narrow path from the Arctic to the Spanish coast, the moon's shadow will race across the planet at extraordinary speed. Day will briefly become night. The corona will appear, and for a few minutes, 3 worlds separated by hundreds of millions of kilometers will look perfectly aligned. Not because they are colliding, but because from exactly where we are standing, they almost perfectly fit.